Hello, everybody. This is Farouk Muzaffar with Exium, and I'm here today to show you what our secure access service looks like. And I'm going to demo for you our admin console, show you some of the capabilities that it has, and actually just focus on our secure private access service, which is essentially it's a zero trust replacement for legacy VPNs. And I'm going to start with just showing you our admin console, how it looks. This is the website, and it's got all the different categories, lots of different sections, dashboard, users, policies, gateways, etc. And I'm going to start with just showing you a diagram. This is actually one of the gateway setups that we have here. There's actually a number of them, but I'll show you this one first and explain at a high level how our secure private access service works. We have a number of users. They're using each of these users will be using a client similar to this one right here. This is our Exium client for Windows, and it shows that I'm connected to California. I'm in California. I'm connected to our node in California, and so users use a client to connect to our secure mesh, which is essentially different nodes in the cloud distributed globally. I'm connected to one in California, and then any other user wherever they are at would connect their local node, and then on the private application side, we have what we call a cyber gateway or CGW, and that is basically a software gateway that runs on x86 hardware. So it's very standards based. It can run pretty much in any location, and it is what provides secure connection to these private applications. And this in this case, this is running actually in India, and we have that gateway is connecting to its local node in India. And so what this diagram is showing, the animation is essentially showing that there's a secure connection, the secure network is up between these users and that gateway and then those applications. But what it's also showing is that out of these four applications, one is actually down. So this application at this address, this device is actually, it's not up and running. The other ones are. Those are test environments, so there's always something going on. But it tells you exactly what's happening with this part of your network. Now, the really interesting thing is that, with a VPN, that would be it. You wouldn't even actually see the health of the devices. You would just, a VPN basically would be a point-to-point connection between the user's PC and the VPN hardware in the data center. And, once the user connected, they would have access to the entire network there. But here we have uh, something called trust paths. This is essentially what is a granular policy that allows this user group to access these applications, and it's you have to specify exactly which applications the users can have access to on this subnet, and so it's not a all or nothing. It's very granular, and that is a key improvement over VPNs that our secure access service implements. um, so that's at a high level how things work. A little bit about users. You can create users directly in the portal. You can also import them, upload. We also integrate with Okta and Active Directory and other identity management software services out there. So you can use those. So there's a number of different ways to bring in users. You organize users into groups, and then you can put policies around groups. Whether those are policies for accessing uh, private applications or for internet policies. So here I'm just showing you, the various policies that we have going on in our environment. This is again a test environment. So there's a lot of different things going on. Somebody's testing blocking Google. Somebody else is blocking Twitter. There's a lot of different. You can essentially do individual IP addresses. You can do entire URLs. There's a lot of different things you can do in terms of having controlling which websites your users have access to. If you don't want to do it at the individual level, you can also do at the category level. So here, we're in this for our workspace. For example, we're blocking illegal content, hate content, social networking, and so on. So you can select which things you want to allow, which ones you want to block, and then it basically implements that policy for your users. So let's jump over to the actual dashboard and show the data for this environment. So this is for the last 7 days. We have 42 users in this environment, and this is what actually is going on. This is the result of the policies being implemented. We can see that most people are using Windows. There's some Mac, applications. Gmail is the heaviest use. We're all on Gmail in this company. We also use plenty of Microsoft as well, and then there's other things like Outlook and so on. Um, um, as far as blocked applications, you saw in the policies that we were blocking, social networking. Facebook gets blocked, and a lot of this is going to be. This just shows how strong Facebook's network is. Even though people are probably not going directly to Facebook, this is blocking ad links in various websites that people are visiting, and where people are coming from. A lot we have employees in India. This is the Roy cities outside of Dallas. Greenwood, Philly, etc. People are distributed all over the place. Then you can see what threats were prevented. Which rules are being implemented to protect our users. Which IPs are being blocked. This is at the aggregate level. We'll get down into the granular level. We could also see the digital experience. What kind of performance are our employees getting when they go to like Salesforce, or here we can see that they get very good latency for Azure, GCP, AWS, but when it comes to like Workday, it's much higher. So they're not getting the best performance on some of these SaaS applications. Things like Salesforce, Salesforce is right on the edge there. It's a little bit, it could be better. Gmail is doing pretty good. So we measure latency to important SaaS locations as well as global destinations like different cities around the world. What are our users getting? And here we can see Buenos Aires, for some reason lately over the last 7 days, hasn't had the best performance. And you can drill into that if you're interested. And then you can also see the user level, what's happening with each of the individual users. Which users are uh, driving the most data usage, who's doing the most transactions, which applications are getting used, and by whom. And then you can also see the individual, events for users. When, for example, in this case, today is December 7th. About 20 something minutes ago, maybe 30 minutes ago, Mike Casey had, a rule violation, trying to access this IP address. So some application on his device, hit this rule that it shouldn't. This is the IP address that it was trying to address. It was trying to get to, and we blocked it. And so and tip basically means a threat. We blocked it because we suspected this to be a threat. So something's going on his PC or on his device, and then you can get down into you can see all the different individual events, and you can see them. You can see a lot of detail around each event as well. You can see the exact requests and protocols and so on. If I want to filter this for myself, I can go down from 42 users that were being shown previously. It should now it's just down to one user. This is just me. It's just my data individually. So you can do that, and you can get very granular into that. See all the individual events just for me. So very powerful, both in terms of the capabilities it has for secure access, as well as the analytics and the data that it has for what's actually going on in your network. Hope you enjoyed this. Check out our website at exium.net, and look forward to hearing from you soon. Take care.